In the previous video, we began discussing reference and value types with classes, structs, and enums. In this video, we're going to take a look at Swift's flow of control features as well as optionals. By now, we're all familiar with Swift's for-in loops, which allow us to iterate over every element in an array without the possibility of indexing outside of the boundary of our array object. In this example, we iterate over a range by utilizing Swift's range operators. This syntax makes for an excellent replacement for the traditional C-style for loop. I should note that as of Swift 3, the traditional for loop will be deprecated in Swift. This for-in loop can easily be modified to iterate over a dictionary by replacing our single variable with a tuple of variables like so, and rather than iterating over a range, we'll change our data source to iterate over a dictionary. We can take this syntax a step further by adding a filter to our loop. Here, we'll iterate over a dictionary of words and return only the items whose keys are even. Swift 2 also introduced another for loop, the for case in loop, which we'll look at in the next video, What's New in Swift 2. As with many other languages, Swift also has a while loop, which, prior to Swift 2, utilized the familiar do-while syntax. Swift 2's version replaces the do keyword with a better-fitting repeat keyword. Do is now reserved for other purposes in Swift, which we'll look at in the next video. In this simple example, we're repeating the word hello while our count is less than 10. Of course, this is pretty straightforward and really doesn't need any further explanation. Now, switches, on the other hand, are exceptionally noteworthy in Swift because they have brilliant pattern matching capabilities. Here's an example of a simple switch statement which has a familiar syntax to many other languages. It's important to note, however, that in Swift, we don't need breaks. Breaking after each case is default in Swift, since a case does not automatically fall through to the case beneath it unless we explicitly tell it to. Rather than using a traditional fall-through approach, Swift allows us to use a comma-separated list, which allows for some interesting capabilities. For example, our current switch is not very exhaustive, so we can continue adding vowels after A to capture all of the possible vowels. Now, of course, we could leave this switch statement as is to capture every vowel, but what if we wanted to make a more specific list or even test for numbers? To show off some of Swift's pattern matching capabilities, we can add a case with a range from A to Z, and the compiler will recognize our pattern and allow us to filter characters. This is interesting, but we can take this a step further. We can change out our characters for ranges of alike words, case 1 ranging from the word any to the word apple, case 2 ranging from the word baby to buffalo, and case 3 ranging from Cayman to cousin. Our switch will automatically pattern match and sort incoming words into the proper case, like this. Swift switches can do more complex pattern matching as well. We'll pass a tuple into our switch that represents a latitude and longitude. Our first and second cases will match our variables as long as they're within a specific range. Of course, this is a simple example, and the numbers are loosely based on reality, but you get the idea of how powerful switches can be in Swift. To see more examples of what you can do with Swift switches, see this video's resource page. Let's finish up this video with a quick discussion on optionals. A very common pattern in programming is to have an operation that may or may not return a value. In some languages, like JavaScript for example, when coming across a null value, our program continues to operate just fine, as long as our program is not dependent on the value to continue. In other languages, like Java for example, a null value can create a null pointer exception and crash our program. Swift's solution to this problem is optionals. By default, if we define a variable without a value, the compiler will complain. So in order to declare a value that may or may not have a value at runtime, we need to add a question mark, which is known as wrapping our value in an optional. This is because we are indeed literally wrapping our value in Swift's optional type, thus giving it a value. To get a better picture as to what I mean by wrapping, we can look at how Swift's optional type is defined in the Swift standard library. If we print out a wrapped optional to the console, we'll see something like this, which is of no use to us. In order for us to use our value, we'll need to unwrap it. There's a few ways to do this. We'll cover the most common ways here. The first way is called force unwrapping and should only be used when we're positive that our variable will contain a value or when you actually want your program to crash if the value is nil. After all, there are times when your application simply cannot continue functioning without the expected value. In those situations, if we force unwrap a nil value, our program will immediately crash. In most cases, however, we'll want to unwrap our optionals in a much safer manner, like using an if-let statement, for instance. If-let allows us to attempt to create a new variable by extracting or unwrapping our optional value. If our optional has a value, our if-let assignment is successful and the value can be used. If the value is nil, our assignment fails, but at least we're able to provide a default value to stop our program from crashing. If-lets come with their own baggage, however, and aren't always the right choice for every circumstance. For example, unwrapping deeply nested optional values can result in a pyramid of doom situation, which looks like this. This happens because the if-let variable is only available within its own scope, causing each unwrapped value to nest in succession. Fortunately, Swift 2 resolves this pyramid of doom situation by introducing a new keyword called guard, which we'll cover in the next video. In this video, we looked at Swift's unique for-in loops and switches, and we also learned a bit about optionals. In the next video, we'll review the features added in Swift 2.